Good evening.
Good evening, ma'am.
Good evening, ma'am.
So we were seeing the standard transformation. Now we will see the last transformation in that. So what are the transformations we have seen? W equal to C plus Z, W equal to CZ, W equal to 1 by Z, and W equal to Z square. These are the four transformations we have seen. So now next we are going to see the next standard transformation. W is equals to E power Z. Okay, so as usual, what you have to do is you are going to find the transformation equations. To find the transformation equations, you are going to replace W by U plus IV and Z by E power X plus IY. This you can split it as E power X into E power IY. So what is E power X into E power IY? So cos Y plus I sin Y. Okay. Now you can split this as E power X cos Y plus I into E power X sin Y. Okay. Now this is U plus IV. What are the transformation equation? U is equals to E power X cos Y and V is equals to E power X sin Y. Okay, to do the transformation, instead of this equation, what you can do is, you can do one thing, you can add, find U square plus V square. What will be U square plus V square? It will be E power 2X into cos square Y plus E power 2X into sin square Y. Now what are these equations? So U square plus V square equal to E power 2X. This is one equation. The other equation is you can find V by, what will be V by U, ma? V by U will be E power X sin Y, E power 2X sin Y, sorry, E power X sin Y divided by E power X cos Y. So E power X will be getting cancelled. V is equals to tan U. Okay, so you can use even this as a transformation equations. So U is equals to U square plus V square equal to E power 2X. V is equals to tan U. We will use this equation instead of having the trigonometric functions. To avoid that, I am rewriting it in this form. Okay, so U square plus V square equal to E power 2X and V is equals to tan U. So these are the transformation equations I'm going to consider for the standard transformation W equal to these. Now we will try to discuss again the different type of cases. Okay, so case one you take. Suppose you
Ma'am,
take,
ma'am, won't it be V equals U tan Y?
what dear?
I mean,
Oh yes, U tan Y only I wanted to write. Sorry, U tan Y only. I mean I wrote it off as tan Y. Sorry, ma. It is V is equals to U tan Y. Yes. Okay, now we'll take the case one. Case one, suppose I consider some X is equals to A. So you know X is equals to A is a straight line. So what will happen when I substitute in this transformation equations? I will get U square plus B square is equals to E power 2A. Okay, what is this, ma? U square plus V square equal to E power 2A.
it's a circle.
Which is a circle with the center at the origin.
And radius E power A.
Very good. Radius E power A, which is a circle with center at 0, 0 and radius E power A and radius E power A. Okay. Similarly, we will take the other one. Okay. We have taken X is equals to A. So similarly, we will try to find X is equals to 0. What is happening when X is equals to 0? When X is equals to 0, you will get U square plus V square is equals to 1. Again, what is
1.
this? This also represents a circle. What is a circle? This is a which is a circle with center at origin and radius 1. Okay, and radius 1. Is it clear? Okay. Now we have done for X equal to A and X equal to 0. Now we will discuss the other cases. Okay, we will discuss that. Suppose we take Y is equals to 0. Suppose we take Y is equals to 0. When we take Y is equals to 0, can anyone tell me what it will be? V is equal to U tan 0. What is tan 0, ma? What is tan 0?
0.
0. So you're getting, when Y is equals to 0, you're getting V is equals to 0. Okay, when Y is equals to 0, you're getting V. Similarly, you take some other line Y equal to B. When you take y equal to b, you will get we will get p is equals to u tan b. What is this, ma? What is this? Why v is equals to u tan b? What it represents? It represents a circle, straight line, or any other curve. What is this? Parabola,
Line.
hyperbola. Very good. It is a straight line, okay, which is a straight line passing through
Origin.
Origin.
passing to origin. Very good. Which is a straight line. Oh, sorry, I write down. Please write down. Which is a straight line passing through the origin. Okay. Now you have got what all you have got? You have got two concentric circles because one was with the radius 1, other one was the radius e power a. We don't know which is what. According to the constant, it's going to change. And other than that, you got v is equals to 0. So this is the line. Sorry, this is the line v is equals to 0. This is the line v is equals to 0. Other than that, we have got v is equals to u tan b. V is equals to u tan b, which is a straight line. Now, to mark this region, we will discuss the other cases also. Okay, we will discuss other. Put, what is that? Wait a minute. Take this as equation number E. Yeah, take this as equation number 1. Take this as equation number 2. Okay, take this as equation number 1 and take this as equation number 2. We have to tell x q is equal to a, x equal to 0, y equal to 0, and y equal to b. Okay. Okay, we will even discuss. Oh, this is enough. 4 points are enough, not necessary. Again, you will get back the same equation. If you take some x is equals to a, or x equal to b, or x equal to 3, x equal to 4, you are going to get back the same equations. So therefore, you can simply write down. So what is the W plane? We got it. So in the Z plane, let us draw in the Z plane. So we have taken X and Y axis. We have taken some X is equals to A, and what is that we have taken? We have taken some X is equals to 0, this line. Then we have taken Y is equals to some B, Y equal to some B, and Y equal to 0. So this is the region it's like. So this is in the Z plane. So what is the corresponding thing we have got it? Sorry. Got it? Correspondingly, one is with the unit 1, the other one is with unit e power a. Other than that, we got this line, and we got this. So which will be the region, ma? Will be that region. So because two concentric circle touching this line and this line. Is it clear? This is in
Ma'am,
the
there is
W.
that V is equal to U tan B line also.
I didn't draw that, right? Okay. Oh, yeah, that line is passing through the center of the origin, right? Correct. Wait a minute. What all we got it? We got for x is equals to a, we got one circle with this. Suppose this is that circle, and for x is equals to 0, we got this circle, the center circle. Okay. And other than that, what we got, ma? What is that we got?
B equals
For
to
For
y
Y
is
0.
equal to B,
y
we
is
got
this line we got. And other than that, one line, correct? This line we got. So in that case, this will not be there. This region cannot come. Oh, sorry. In that case, this region will not come. Okay. Is it clear? Yes. this is about the standard transformations. So all the standard transformations are important, based on which the problems can be asked, and few problems I have done. And for all these things, you'll have only to general case. If they ask the C power Z, W equal to 1 by Z, sorry, W equal to Z square, all the standard transformations itself is important. So they can ask you the standard transformation. Sometimes problems based on that also can be asked. Okay, that will be simple problems as I have done already. Okay, now we will move on to the next topic in this. It is bilinear transformation.
Can you show the first page just once?
Okay, ma, wait a minute. Bilinear transformation. This one?
Yes, ma'am. Okay, thank you, ma'am.
Okay, before going to the bilinear transformation, I just wanted to ask you, what is a conformal mapping? What is a conformal mapping?
Magnitude and direction both are mapped, preserved together.
Very good. Okay, which preserves, that is the transformation which preserves both in magnitude and the direction is known as your conformal mapping. Can anyone now define the conformal mapping in terms of complex number? How it will be? In terms of a complex number or complex function. You can just take down a mapping. Because I didn't give you the definition on that day. A mapping W is equals to f of z. A mapping W is equals to f of z is said to be conformal. At the point z is equals to z naught, is said to be conformal at the point z is equals to z naught if the derivative of the function at the point z naught is not equal to 0. That means what? The derivative should exist. If the derivative it is existing only, it is an analytic function. For the analytic functions only, we are seeing conformal mappings. You understood? I said you one more topic on that day. This is for conformal. What is isogonal?
Only magnitude is preserved, not the direction.
Very good. It is preserved only in the magnitude, not in the direction. Only in magnitude, not in direction. This is both in magnitude and direction. Both in magnitude and direction. Okay. The point at which, now listen, the point at which it is not conformal is said to be a critical point. So for that, this definition only I wanted to give you this. So you have a critical point. Critical point. You can just take down a point at which the mapping, a point at which the mapping W is equals to f of z, W is equals to f of z is not conformal, That is, the derivative of the function f of z is equal to 0 is called critical point. Is called critical point. Is called critical point of the mapping. Critical point of the mapping. Now listen, W is equals to f of z is a function. Similarly, what will be the inverse? What will be inverse of this? Z is equals to f inverse of W. If this is conformal, the inverse will also be conformal. Sorry, if suppose this is, sorry, suppose this is conformal, this also will be conformal. Okay, if this is conformal, this also will be, the inverse transformation will also be conformal. That we have already seen, z by 1, W equal to 1 by z. It is also, it has, we did the transformation, right? So the inverse transformation will also be conformal. Okay, next you should know one more point in this. Fixed point. or invariant points. Fixed point or invariant points. You can even call them as a critical points also. Fixed points or invariant points. Fixed points are invariant points of the transformation W is equals to f of z are the points that map to themselves. Are the points that maps to themselves. Okay, suppose the fixed point of a transformation W equal to f of z are the points that mapped onto themselves. Write down. The fixed points are points that mapped onto themselves. So in that case, W is equals to f of z is a mapping means you have to find the fixed points transformation means put it is mapping to the same point. So z is equals to f of z. Z is equals to f of z. So this is this when you solve this, you get the points. That points are known as fixed points are invariant points. Those points are called as fixed points are invariant points. So you should know all these things, different type of points, because next topic, the bilinear transformation, we are going to talk only about the points. Okay, so you can understand. Next, you are going to see bilinear transformation. What is bilinear transformation or Mobius transformation? Other name is Mobius transformation. A transformation of the form W is equals to AZ plus B divided by CZ plus Z. A transformation of the form W is equals to AZ plus B divided by CZ plus D, where A comma B comma C comma D are complex constants. Where A comma B comma C comma D are complex constants. Okay, complex constants, and AD minus BC is not equal to 0. This is called determinant of the transformation. Determinant of the transformation. Okay. W is equals to AZ plus B divided by CZ plus D, where A comma B comma C comma D are complex constants, and AD minus BC is not equal to 0, and AD minus BC is not equal to 0, then this transformation is called bilinear transformation. So you can understand from the word bilinear. So two linear equations. See, you can see here is one linear equation, here is one linear equation. The two linear equations, put it in this form. Okay, in this form is called bilinear transformation, is called bilinear transformation, or it is called Mobius transformation, or it is called Mobius transformation. The inverse bilinear transformation will also be conformal. First of all, we will check whether this is conformal or not. So how will we check it is a conformal or not? You know that W is equals to AZ plus B divided by CZ plus D. Find dW by dz. Find dW by dz. You will get CZ plus B. When you differentiate this with respect to Z, you will get A minus AZ plus B. When you differentiate the denominator, you will get C alone, divided by CZ plus D the whole square. Okay, simplify this. ACZ plus AD minus BCZ minus BC divided by CZ plus D the whole square. Okay, so ACZ. Oh, this is also A, no more. ACZ and sorry, ACZ plus ACZ minus ACZ will be getting cancelled. So you get AD minus BC. AD minus BC divided by AZ plus D the whole square. So you all know that I'll write it as dW by dz itself. Okay, so you all know that AD by AD minus BC is not equal to 0. Therefore, the derivative exists. Derivative exists. Therefore, the transformation is conformal. The transformation is conformal. Transformation is conformal. Suppose you're writing the inverse of this transformation. Suppose you're writing the inverse of the transformation. This is of the form W. What was the transformation? W is equals to AZ plus B divided by CZ plus D. The inverse will be of the form minus DZ plus B divided by CZ minus A. Minus DZ plus, sorry, not Z, it is where it is a inverse, right? So it will be d omega. be dw. dw plus b divided by cw minus a. We all understood?
Yes, ma'am.
Okay, so this is about the bilinear transformation. Okay, to find the bilinear
Ma'am.
transformation,
Can you explain the inverse one once?
inverse is simple, ma. I'm writing z as this, just interchange it. Actually, we have to derive it. I'm just interchanging this and with the minus sign. The inverse will be of this form. That's all, you remember that. The inverse will be of the form. Actually, we have to simplify this and get back this. That is cross multiply, find the inverse and do it, but directly you can remember.
Okay, ma'am.
If you want, I'll show it. See, if you cross multiply this, what will happen? You will get W into CZ plus D is equals to AZ plus B. You will get. Okay, what we want all the Z terms to one side. You will get W CZ plus WD is equals to AZ plus B. So bring this WCZ minus AZ is equals to B minus DW. Okay, B minus. I did one mistake. AZ plus B divided by CZ plus C, no ma. CZ plus D, correct, only I did right. CZ plus D, AZ plus B, WCZ plus WD divided by AZ plus B. So WCZ minus AZ B minus DW. Yeah, fine.
Yes,
Now what I
ma'am.
want, I want the Z alone, right? So I can take Z outside. Once I take Z outside, I'll get CW minus A. Just bring it to other side. You're getting the same thing, right? Minus DW plus B divided by minus CW minus A. That's all. Simple one only. We cross multiply and bring back this. So directly you can remember. I'm interchanging these two and adding the W. That's all. You understood, right?
Yes, ma'am. Thank you.
Okay. Okay. Next, I need to say you to find the bilinear transformation. Take down to find bilinear transformation. To find bilinear transformation. To find the bilinear transformation which transforms three distinct points into three specific distinct points. Okay, to find the bilinear transformation which transforms three different distinct points into three specific distinct points. The formula is, just concentrate. See, W minus W1 into W2 minus W3 divided by W1 minus W2 into W3 minus W. Just remember, see, W 1, 2, 3. 1, 2, 3 W. See, every book has a different form. You can write it in any other form, but this will be easy for you to remember, so that it's easy. Similarly, on the right hand side, you can write it as Z minus Z1 to Z2 minus Z3 divided by Z1 minus Z2 into Z3 minus Z. Again, the same form I have maintained, 1, 2, 3, 1, 2, 3. So that you can remember the formula easily. Is it clear?
Ma'am, can you please repeat the statement once again?
Which statement here? The three distinct points are mapped.
Yeah.
See, what is the transformation? You're going to see transformation of one curve to the other curve. Okay, so how are the 3 points in the Z plane are mapped to the W plane with the 3 distinct points? That transformation equations are given by this. So directly you can take this. With 3 points means you can use this. W minus W1 equal to W2 minus W3, Z minus Z1 equal to Z2 minus Z3. Similarly, W1, W2, W3, W you have. Is it clear?
Yes, ma'am.
Okay, we'll do one problem. Just take down. It's 4:30, fine. We can do one problem. Find the bilinear transformation. Just concentrate. Anyways, I'm going to upload it. or I'll give you time to write. First concentrate. Okay. Find the bilinear transformation that maps the points Z1 is equals to minus I, Z2 is equals to 0, Z3 equal to I. And similarly, W1 is equals to minus 1, W2 is equals to I, W3 is equals to 1. So you have to keep changing the pages. So if I'm wrong, you just tell me. So you know, these are the three, no, I didn't complete the question. Find the bilinear transformation. Find the bilinear transformation that maps the points. Find the bilinear transformation that maps the points Z1 equal to I, Z2 equal to 0, and Z3 equal to I into the points W1 equal to minus 1, W2 equal to I, W3 equal to 1. W3 equal to 1. Okay, so we know that what we know, the bilinear transformation is given by bilinear transformation of 3 points. Okay, is given by Z minus Z1, or I can write it in terms of W and Z because we have that form only, right? So W minus W1 into W2 minus W3 divided by W1 minus W2 into W3 minus W is equals to Z minus Z1 into Z2 minus Z3 divided by Z1 minus Z2 into Z3 minus Z into Z3 minus Z. Now what we are going to do, we are going to substitute the values of W1, W2, W3 and similarly Z1, Z2 and Z3. Okay, so let us substitute. Anyone has written the question? Everyone has written the question, right?
Yes.
Okay, just
Yes,
tell
ma'am.
me.
Yes, ma'am.
Just tell me what is W1, ma?
Minus 1.
Minus 1. So minus of minus, this will become plus 1. Similarly, what is your W2? It is I.
I.
W3 is 1 divided by W1 minus W2. W1 is minus 1. W2 is minus I into W3 minus W. So 1 minus W is equals to Z minus Z1. Z minus Z1 means Z plus I into Z2 minus Z3. Z2 minus Z3 is 0 minus I. Okay, divided by Z1 minus Z2. Z1 minus Z2 is minus I minus 0 into Z3 minus Z. Okay, what did I do? I just substituted these points in these values. That's all. Okay, now just concentrate. Now we will do step by step. Okay, so I can write this as 1 plus W divided by 1 minus W. Bring all other quantities to one side. So before bringing, you can little bit simplify it also. So I can write this as 1 minus I divided by 1 plus I. I have taken 1 minus sign from this and I have multiplied that minus sign here. So I'm getting 1 minus I by 1 plus I. And here this side, I'll write it as Z plus I into minus I divided by minus I into I minus Z. So minus I will be getting cancelled. Is it clear? Minus I will be getting cancelled. So I'll get 1 plus W by 1 minus W is equals to Z plus I divided by I minus Z into cross multiply this. So I'll get 1 plus I divided by 1 minus I. 1 plus I divided by 1 minus I. What I'll do is I'll multiply by 1 minus I and divide and multiply by 1 minus I. Okay, I'll multiply by, sorry, divide by conjugate. 1 plus I, 1 plus I. Now what will happen? My left hand side is 1 plus W divided by 1 minus W. Divided by 1 minus W. My right hand side I have Z plus I divided by I minus Z. I minus Z. And here you have 1 plus I the whole square divided by A plus B into A minus B. A plus B into A minus B is what, ma?
A square minus B square.
A square minus B square. Here you have I. What it will be?
Minus 1.
Minus 1.
1 plus 1, 2.
2.
Yes, ma'am. 2.
It will be A square plus B square, right? It will be 2. Okay. So in the numerator, you'll get 1 plus I the whole square divided by 2. divided by 2. Is everything is clear till now? So now listen. So this will be z plus I. Expand this. A plus b the whole square. A square plus 2ab plus b square divided by I minus z into 2. So plus 1 minus 1 will be getting cancelled. So you will get z plus I divided by I minus z into 2i. Into 2i, okay, into 2i divided by 2. 2 and 2 will be getting cancelled. So you will get I into z plus I divided by I minus z. I into z plus I divided by I minus z. But what we want on the left hand side, we want in the left hand side is only w. W is equals to az plus b divided by cz plus d. That is the idea. You can multiply this I also inside. So once you multiply this I inside, you'll get 1 plus w by 1 minus w is equals to, when you multiply this, you'll get iz minus I. Sorry, iz minus 1. Iz minus 1. I square will become minus 1, right? Divided by I minus z. Divided by I minus z. What is the advantage if you multiply? There is no advantage in multiplying this. Fine. Next one, we will apply componento dividendo rule. Dividendo. What does the componento dividendo rule says, ma? A by b is equals to c by d will be equal to a plus b divided by a minus b will be equal to c plus d divided by c minus d. To understand, it says that a plus b into this will be equal to this. So we'll apply this. So I'll get 1 plus w plus 1 minus w divided by 1 plus w minus of 1 minus w is equals to iz minus 1 plus I minus z divided by iz minus 1 minus of I minus z. Okay, now see, listen, plus w minus w will be getting cancelled. You will get 2 divided by 1 plus w minus 1 plus w. So minus 1 plus 1 will be getting cancelled. You will get w there. And here you get iz minus 1 plus I minus z divided by iz minus 1 minus I plus z. Is it clear? Now in the left hand side, you have 2 by 2w. Have 2 by 2w. In the right hand side, combine the terms. Z terms together, other terms together. So when you combine the z terms, you'll get z into I minus 1. You'll get z into I minus 1. Okay, see this term and this term I'm comparing. If I take z outside, you get z in. And here also, if you take one minus sign outside, you get I minus 1. Correct, ma? This minus sign outside, you get I minus 1. Let's say we want minus 1, right? And by write it as
Plus sign.
second,
Yes,
right?
but should be plus 10.
Plus summa divided by similarly here also I can combine the terms. If I take z outside, I'll get I plus 1. Okay, from the balance and if I take minus sign outside, I'll get I plus 1. Okay, now 2 under 2 will be getting cancelled. You'll get 1 by w. The right hand side, you can write this as z plus 1 into I minus 1 divided by z minus 1 into I plus 1. Okay, again you can multiply with the conjugate. Once you multiply the conjugate, you'll get with the conjugate of this 1 minus I into 1 minus I. Okay, 1 by w is equals to z plus 1. Multiply this one. When you multiply this, you get I minus 1 minus I square is minus 1 minus this will become plus 1 minus 2 minus plus I divided by get z minus 1 into when you multiply this a plus b into a minus b you'll get 2. Okay, in the numerator plus 1 and minus 1 will be getting cancelled, you get 2i. Okay, you will get 2i. So 1 by w will be equal to 2i z plus 1 into 2i divided by
Ma'am, it should be -2.
where dear? Where minus 2? Two and a 2 will be getting cancelled. So what is your w? W will be equal to z, sorry, z minus 1 divided by 1 plus or z plus 1. So we want cz plus d divided by dz plus c. So you can write it as z plus 1 into I. If you multiply by the numerator and denominator, so you have I here. So again, you cannot leave I in the denominator. If you multiply this, you'll get minus I into z minus 1 divided by z plus 1. This is your required bilinear transformation. This is your required bilinear transformation. Perfect.
Ma'am, could you go on the previous paper once?
Slowly you do. You have to bring the form W is equals to Cz plus D divided by DZ plus, sorry, AZ plus B divided by CZ plus D. That's it. Well understood? I did step by step.
Yes, ma'am.
Ma'am, you multiplied 1 minus I.
Where dear? Conjugate, right? 1 plus I conjugate is 1 minus I, right?
Ma'am, I thought you should have multiplied I minus.
Why will I multiply I minus 1 here?
Conjugate.
Conjugate of x plus iy is x minus iy, right? So in
Yes, ma'am,
that
imaginary part changes the sign.
anyone has any other doubts in this? Did you understand bilinear transformation? Simply keep doing it. However you get, you keep doing it, you will get the answer. And suppose for this problem, they are asking you to find invariant points. Invariant points for the same problem. You can just include here. Also find invariant points. Also find its invariant points. Let me tell you here itself. What is your invariant points? Put W is equals to Z. This is your, because the image of that point is itself. Image of the point is itself. Then only we say that it's invariant point. So in that case, you'll put Z here. The place of W you'll replace by Z. In here you'll get minus I into Z minus 1 divided by Z plus 1. Now cross multiply. When you get Z square plus Z is equals to minus I into Z minus 1. So Z square plus Z is equals to minus IZ plus I. Minus IZ plus I. Bring all the other terms to one side. So once you bring it to the other side, you'll get Z square plus Z plus IZ minus I equal to 0. Okay, this you can rewrite it as Z square plus 1 plus I into Z minus I equal to 0. It is a quadratic equation. It's a quadratic equation. So find Z by minus B. Minus of 1 plus I plus or minus square root of B square. B square is 1 plus I the whole square minus 4AC. I'll do it in the next page. So what is the equation I got? Z square 1 plus I into Z minus I. Minus I equal to 0. Okay. Now listen, minus B plus or minus square root of B square minus 4AC divided by 2 into A. Okay, this will become minus of 1 plus I plus or minus, please mute yourself, A square plus 2AB plus B square. B square will give you minus 1. Okay, minus 2 minus plus 4I divided by 2. Simplify this. You get minus of 1 plus I plus or minus square root of how much you'll get? Plus 1 minus 1 will be getting cancelled. You'll get 6I. Okay, 6I divided by 2. That's all. You can leave it as such. If it is getting simplified, you simplify. Otherwise, these are your invariant points. These are your invariant points. Is it clear? You can leave it like this. There are two invariant points. What are the points? Minus of 1 plus I plus root 6I divided by 2. Other one is minus of 1 plus I minus root 6I divided by 2. So there are two invariant points. You have got a quadratic equation. So whenever you have to find the fixed points or invariant points, the image of the point will be itself. That is, then we say that the invariant points of the transformation is this. Have you all understood? If you have any doubts, you can ask.
Yes, ma'am, understood.
Other problems we'll see in the next class. Okay.